Hostic lineman. Rick Pazza, chief Hostic lineman. Sean Gilliland is a Hostic lineman, and I'm also a Hostic lineman. It takes about 5 years from the time you start the apprenticeship till before you can be qualified as a Hostic lineman. And so once you're there, you can work up to 64,000 volts. The gloves and sleeves that they're wearing are rated for 15,000 volts, and the sticks here are rated for 100,000 volts. Oh, chief Hostic lineman. I forgot that part. Yeah, and we're all members of Local 97 that's based here in Syracuse. The first thing we're going to talk about is you see on the news whenever storms roll by, they'll say get ready because the power might go out. Get your lights and water and generators ready. So when there's storms, you kind of expect your power might go out. But if it's a nice day like today and your power goes out, a lot of reasons it's because of something like this. Because animals like squirrels, raccoons, birds, sometimes they knock the power out. Once I seen a frog at the top of the pole, and the frog actually took the power out. I don't know how the frog got up there. But some people have seen fish that birds dropped on the wires, and so it's animals are a big problem sometimes. So we have Rocky the squirrel here. He's climbing up the pole. He's climbing up the pole. He's looking to get some food. And that's what Rocky looks like right there at the end of it. So right there is a fuse. We have throughout our system we have it fused like that. So if something happens, everyone on that side of the fuse still has power, but everyone downstream doesn't have power. So it feeds into the top of the cutout and down. So when there's a problem with the line, the fuse will blow, and then it's a safety precaution, and it helps keep other people's lights on. So now we're going to talk about there's a household glove here. It's made of rubber. It's not like the rubber we wear because ours is made for electricity. So now this is a household glove, and the fence is energized at 7,000 volts. So here's what happens if you come close to it. Yeah, that's 7,000 volts of electricity right there. So now we're going to put a stick up there. And because with storms, lots of times trees come down, branches come down, they knock wires down. And if you see wires down in your yard, don't go around them. Just call the number. We'll come and make the area safe for you. Because here's a tree limb. It's going to be touching the wires here. And if you're touching the bottom of that tree limb, even if it's 40 feet long, the electricity is going to go through you too. So you don't want to come anywhere near trees if there's wires around. So now we're going to do a ladder because sometimes people are doing work on their house, like putting shingles up or doing some roofing, even doing painting. And you got to look up ahead of you first, make sure there's no wires around. You're supposed to stay 10 feet away from all our wires. So now if you're on that ladder, there's going to be 7,000 volts going through you to the ground. And that's one of those mistakes that you only make once, because you're not going to be around to make it again. So just be safe, look up, make sure there's no wires around before you're working. And also related to storms, when wires come down, sometimes the phone wires get wrapped around our electrical wires. So even if you know what electrical wires look like and the difference between phone wires and electrical wires, they can still carry a current. This is a coaxial cable, it's just a regular telephone cable, but it's attached to our wire at the top. So phone wires can be electrical wires also. So just because you think it's a phone wire and it's on the ground, it still could be carrying electricity in it. So if there's wires on the ground, just call the number and someone will come clean it up for you. Next, we're going to show a fireman's boot here. And that is rubber, but it's not made for electricity. The boots we wear at work, they're all electric hazard boots. And we have to wear fire retardant clothing. All the clothes that we wear are fire retardant. So in case we do make a mistake or something happens, and there's a flash in front of our face like the arcs that you're seeing, then the clothes don't melt to her body. So that's a nice thing. So here's a boot, touching ground. So now, even if you have a big rubber boot on like that, the electricity could still flow right through you. Next, we have a fireman's hose here, and we're going to have the electricity coming up through here, through this transformer, going to the top of this cutout. There's going to be a fire hose here. It's going to go through this cutout here, and watch the street light. These ones here out of the metal, those are rated for 300 amps. And this here is just a regular fire hose. But keep an eye on that lamp here, because the electricity right now is going to be going through here. Right now it stops up there, because there's an open. But so right now it's only hot to the top of that cutout. But once he touches the top of the cutout with that wet hose, keep an eye on that light. So now there's 7,000 volts going through that light, through that wet hose there. It's going to the transformer, it's getting converted to 120 volts, and it's lighting the light. So electricity can and will travel through just about anything. All right, the next topic is the generators. If you have a generator, make sure it's hooked up right. You should have a disconnect switch. It's for your safety and for ours. Because if it's not hooked up right, we could be out there fixing wires after a storm, thinking that the wires are dead, but someone doesn't have a generator hooked up right. So now they're going to be backfeeding onto our system, because right now it's going out of the generator, through the meter, back up onto the wires, and now the light's back on. But if it's hooked up right like that, your electricity will stop at your disconnect switch. So that's for your safety and for our safety. All right, next is another one of those things when your power might go out when it's nice out and you're thinking, there's no storm, why is the power out? We have a big problem with people texting and driving, people drinking and driving, people eating and driving, people reading the newspaper and driving, and they'll crash into a telephone pole or utility pole. So the simulation here is the truck's going to be energized at 7,000 volts. And if you try to get out of the car, there's 7,000 volts going through you there. So if you get in an accident and there's wires on your car, you're supposed to stay in your car until someone comes to save you. And what they tell you to do is to do a bunny hop when you get out. The only time you should get out is if your car's on fire or you're in danger. And to do that, you have to jump with 2 feet as far as you can until you get away from the car, because if you try to step, it's called a step potential with electricity. So this foot's going to be at a different potential than that foot, and the electricity is going to go through you. But if your feet are together and you jump, then it's a bunny hop away from the car, you'll be okay. So now here's another one. The last time we had the 300 amp blades in there, so the electricity just kept pumping through the wires. But now there's an accident and there's a fuse here.
Your lights went out.
And that's the end of the show. If you guys have any questions, we'll be around to answer any questions you might have. Thanks for coming.